same. Okay, so if you learned GSM, CDMA will be remain same. Suppose if you know the CDMA, then GSM will be changed. So here what we are going to do, so we are going to just drawing the graph. Okay, so how to draw the graph and what exactly this GSMA and CDMA, let us discuss. Okay. So everybody knows, the in earlier days we were using the mobile phones. Okay, so we were not having mobile phones. Okay, so earlier days we were charging while calling also, we'll be charging, and then again the person who is receiving the call, that person will also be get charged. Okay, that was the trend we had seen, we were having in the earlier days. Okay, so with the rapid growth in the technology. Okay, so with the rapid growth in the computer and the communication technology, so the mobile phone or the communication technology has brought a lot of changes and innovation in the field of the communication technology. Okay, so earlier days we were using like a 2G, and now it has been updated to 3G. Now it has been updated to LT. That is a long-term evolution. Okay, so here we are going to discuss about a GSM program. Okay, so what we are going to do in case of a GSM, and what is this CDMA. Okay, so GSM stands for Global System for Mobile Communication. Okay, and CDMA is Code Division Multiple Access. Okay, so in case of GSM, we'll be using a SIM card. Okay, so that means SIM card slot is available in our GSM, and in CDMA there will be no any kind of SIM card. That is, your number will be available in the form of a hard coded. Okay, so it's just like what your earlier days we were having, like Tata mobiles and Tata Indica mobiles. Hope you had seen. Okay, Tata Indicom and Reliance Mobile. That kind of mobile phones come up with without SIM card. That means the numbers or phone numbers will be hard coded to that particular embedded system. Okay, and in case of GSM, we'll be using the technologies like FDMA and TDMA. That is a frequency division multiple access and time division multiple access. But here, in case of CDMA, that is a code division multiple access, the frequency technique. Okay, the technology which is used in case of a CDMA is that is a spread spectrum. Okay, so what is the spread spectrum concept? Here the idea behind this spread spectrum is just a extension of available bandwidth. Okay, extending the available bandwidth. So the conclusion point with respect to this GSM and CDMA is the availability of the bandwidth is higher in case of a CDMA compared to a GSM. Okay, so and then with respect to the cost factor. Okay, so we can say the GSM is quite expensive than the CDMA. Okay, so according to your program, right? So the program number of 5, that is the statement is like implement the study and performance of a GSM, that is a global system for mobile communication, use on NS2 or NS3 using MAC layer or equivalent environment. Okay, so what we need to do, we have to implement and study the performance of a GSM. Okay, so we need to plot the graph with respect to or by considering the what the performance of a GSM. Okay, and what is the scenario? Okay, so scenarios here we are going to use a different nodes like a MS1, that is a mobile station one, and then we are going to use one more node as a base station one, and then one node we considered it as a MSC, that is a mobile switching center, and we are going to use one more node as a MS2. Okay, mobile station 2, and we are going to use one more station, station as a one more node as a BS2, that is a base station 2. Okay, and then the link type which we are going to use in case of lab number 5, that is a GSM program, is a duplex link with a bandwidth. Okay, so delay time and type of a queue, so that we are going to define while we are going to writing the code, while with respect to the allocation of a link between the particular node and base station. And the agents which we are going to use in this program is, that is a TCP agent we are going to use, and TCP sync is the two different agents we are going to use. Okay, here in case of a GSM program, and the application which we are using for analyzing the performance of this GSM is a FTP, because as I told, whenever we are using a agent as a TCP, then the application or a traffic generator will be FTP. If we are using UDP as an agent, then we have to use a CBR as a traffic generator, or you can say application. Okay, so here you can see some of the points we have been represented over here with respect to the second generation. That is, a GSM comes under what your 2G technology. That is, second generation technology is based on the technology known as a global system for mobile communication. Okay, so why it is called GSM mobile? So based on this, the generation, that is this GSM comes under the second generation technology. Okay, and this technology will enable various networks to provide the services like text messages, picture messages, and a MMS. Okay, so this technology will facilitate us to provide the services like using text messages or sending and receiving the text messages and sending and receiving the pictures and MMS. Okay, so here the 2G technology is going to use either TDMA, that is a time division multiple access, where we are going to divide the entire signal into the different time slots. Okay, at each time slot, that particular at each time slot, particular system will be operated. That bandwidth will be allocated for that particular system. And again, or else you can use CDMA also. That is a code division multiple access. Okay, so these are what the different frequency division multiple access techniques. Okay, so either multiplexing. These are called as what the multiplexing technique, TDMA and what CDMA. Okay, so which is and you can see one more point, that is the GSM is going to use a narrow band time division multiple access for providing the voice and the text based services over the mobile phone services or over the mobile phone and network. Okay, and the radio spectrum being limited resources, that is consumed and divided among all the users. So GSM devised a combination of TDMA and a FDMA. So TDMA is a time division multiple access and FDMA is a frequency division multiple access. So as the method to divide the bandwidth, okay, so among all the users, because several users may be connected to a single access point. Okay, so we need to divide the total available bandwidth to all the users. Okay, so that cannot be allocated, or the entire bandwidth cannot be allocated for a single users, because they have subscribed, all the users, they have subscribed. That means uh, I am a subscriber of a BSNL, means I have to get the or some sort of bandwidth should be allocated for my usage. That is what the meaning. Okay, so bandwidth should be allocated among all the users. So in this process, the FDMA part divides the frequency of total 25 megahertz bandwidth with a 124 carrier frequencies of 200 kilo bandwidth. Okay, and each base station will be assigned with one or multiple frequencies, and each of this frequency will be divided into 8 time slots. Okay, so using TDMA scheme. Okay, so this is what some of the descriptions with respect to the 2G technology. Okay, so this is what the configuration, or you can say the topology, which we are going to use for a lab 5 program and a lab 6, that is to study the performance of a GSM and a CDMA. Okay, so as I told, here we are going to use this, see, the same topology will be used. Okay, so for implementing the laboratory number 5 program and a laboratory number 6. Okay, so that is, let us consider this is MS1, that is a mobile station. Okay, and this is one more mobile station, call it as a MS2. Okay, so MS1 is a mobile station, and also MS2 is also one more mobile station. Call this MS1 as a source and call this MS2 as a destination. Okay, and connect this MS1 to BS1. So BS1 is a base station. Okay, so this is a base station. Okay, so this mobile station is using this base station, or this mobile station comes under the range of this base station 1. So similarly, this mobile station 2 is in the range of this base station 2. Okay, and then so these base stations can be connected by a MSC. So MSC is a mobile switching center. Okay, so why this mobile switching center is required? So this as the name indicates, mobile switching center. Okay, so when you dial particular number, that call should be connected to only that intended recipient point. Okay, so suppose if I dial number 123, that call should connect to 123, not to 456. Okay, so that switching process will be done by one of the technical team or technical component called as a MSC, that is mobile switching center. Okay, and then we need to attach the agents, that is a MS1 is attached to TCP1, and then FTP1 is application, or you can say traffic generator is attached to this TCP1. Okay, and then the agent TCP sync one is attached to MS2 that is a destination node, right? And then we need to suppose assume that the scenario is like this MS1 wants to send a message to or wants to communicate with this MS2. This mobile node wants to communicate with the mobile station 2 or mobile node 2. So then in that case, how the process will go? Okay, what is the process flow? So here this mobile station is going to be connected to first base station, and then the base station is going to contact the MSC. Then MSC is going to contact the BSC2, because this BSC2 is the access point of this destination. That means, so here this BSC2 is going to notify, or it will be having the information about the destination node or about this MSC node. Okay, whether this mobile node is residing in the coverage area of this BSC2 or not. If not, again the MSC is going to look for the another BSC, another base station. Okay, so this is how the process is going to the process will be followed. Okay, and the link which I have connected between this MS1 and MS2 is again what I told in the beginning, that is a duplex link. And then this is 1 MB is the what the bandwidth what I'm assigning between this MS1 and a BS1, and this 1 ms is a 1 millisecond is the propagation delay. Okay, and again between BS1 and MSC is a 1 MB, I'm assigning the bandwidth, and then 10 millisecond this is a propagation delay I'm assigning between this BS1 and MSC. Similarly for these two link, that is a 1 MB between BS2 and MSC, 10 millisecond again is the propagation delay between BS2 and MSC. And then 1 MB between this MS2 and a BS2 as a bandwidth, and 1 millisecond is the propagation delay between this MS2 and a BS2. So this is what the simple the topology, or I can say the configuration part which we need to configure. Okay, so with respect to the laboratory number 5 and the laboratory number 6. Okay, so next, so what are the steps we need to follow? Okay, so here whatever the steps we have used in writing these remaining or previous 4 programs, so same procedure or same steps will be used. Okay, only 1 or 2 steps will be different. So what is the first step? You can see here. So step number 1, so create a simulator object. Okay, so this is what the regular process which we are going to use in previous 4 program. First step is for we are going to create a simulator object. In the next step, we are going to create the NAM file and a trace file. And then in step number 3, we need to create the number of nodes which are required according to our requirement or convenient. And then we need to create the link. And then here, the one of the extra step what we have, that is a create a cell topology. Okay, so the why we need to create a cell topology here, I'll tell while explain the program. Okay, so we need to create a cell topology, and then we need to add the agent to the source and a destination. Okay, and then set up and transport layer connection. Okay, at a step number 6. At a step number 7. Okay, so this is 7. Add agent application. Okay, and then step number 8, connect the agent at a source and a destination. Then at step number 5, schedule the events. Okay, at what time the event should start and what time the event should stop. And then write the finish procedure, that is define the finish procedure at step number 10. At step number 11, run the simulation. So how many steps we are having in a program number 5? That is around 11 steps we are having. Okay, so only extra thing what we have here in this program is that is creating the cell topology is one of the extra step we need to write. Right, next, so how to write or how to type the program? So this is a general process what we adopted to write the remaining previous 4 programs. That is go to terminal, then again type gedit, give the file name dot tcl with an extension tcl. Let us consider gedit program5.tcl. Okay, then the notepad is going to get open. Then again you need to type the program, save, then compile it. Okay, so similarly laboratory number 6. Okay, so because laboratory number 6 is related to what a CDMA, that is a code division multiple access. Okay, so this is the extension of your GSM technology. Okay, so this CDMA comes under the 3rd generation technology. Okay, so what we need to do again here, we need to implement and study the performance. In both the cases we are studying the performance of these different technology of a mobile communication, that is in terms of GSM and as well as a CDMA. Okay, again, what are the components or what is the scenario we need to use? That is a we are going to use a nodes like a mobile station one, base station one, mobile switching center, base station two, then base station two. Okay, and then the link again same, the agents also same, then application also same. Okay, so the diagram which I shown in the beginning, so this diagram, so that will be applicable or used for implementing both the programs, that is a lab 5 and a lab 6. Okay, so what exactly this CDMA? Okay, so this CDMA comes under the third generation. The 3G networks developed as a replacement of a second generation 2G technology. Okay, so one of the major drawback what we observed in case of a 2G technology is a, so that leads what the handoff concept. Okay, so that creates some of the call connect and a disconnection. Okay, so due to unavailability of a sufficient bandwidth for usage or to make call. Okay, between two any communicating parties. That means we have a what shortage of bandwidth in case of a 2G technology. So that can be overcome in the upcoming technology. So that technology or that generation of technology is called as a 3G technology. That is a third generation technology. Okay, so you can see here some of the points we have mentioned over here. So 3G networks developed as a replacement for a second generation 2G, that is a GSM standard network with a full duplex voice telephony. Okay, so CDMA is used to access the method in many mobile phone standards. So IS-95 is also called as a CDMA 1, and it's a 3G evolution is CDMA 2000. These are the different versions of this 3G. Okay, so and are often simply referred as a CDMA, but UMTS, Universal Mobile Telecommunication System, is the third generation mobile cellular system for networks based on the GSM standard. Okay, and in your mobile phones you can see in the top of your network, you might have seen the keyword, there is a LTE. Okay, so LTE is what, there is a long term evolution. It is a standard for high speed wireless communication. Okay, so which uses CDMA and network technology. That is a 3G technology will be generally referred as a standard of a accessibility and speed of a mobile devices. Okay, so what we need to do again, the same steps we are going to use. That is where we need to create the simulator object, then we need to create a NAM file and a trace file, then we need to create a nodes, then we have to create a link, then we need to create a cell topology, then we need to attach the agent, okay, to the source and destination, then we need to add the agent application, and then we need to connect agent at the source and the destination, then we need to schedule the events, okay, when to start and when to stop, then we need to write the finished procedure, then run the simulation. Okay, so these are what some of the steps we need to use, okay, in order to write the program. Okay, so this is all about some of the basic things about the what your 2G and 3G technology. Okay, so coming to the code part. Okay, so what exactly this code part is describing? So you can see the statement of a program, that is implement and study the performance of a GSM on NS2 or NS3. Okay, so this program, okay, so in your manual program, you can don't no need to follow the manual program because it is quite lengthy. So we come up with one more program, that is the program which we are going to forward you people by today. Okay, so and even I'm going to explaining the same program. Okay, so it is just hardly, I can say, one page of a code part it is having. Okay, right. So how to write the program? So set ns space new simulator. What is this? This is first step of writing the what your fifth program, that is creating a simulator object. Okay, so creating a simulator object, again this s should be capital. Okay, so then next, what is this? Creating the trace file, and then creating the NAM file. Okay, so creating the what simulator object, creating the trace file, and creating the NAM file. Okay, so with the write mode, then what we need to do, we have to again create the nodes. So how many number of nodes we are creating? 1 2 3 4 and 5. Okay, so 5 nodes we are creating. Okay, so here I am giving node name as a ms1, bs1, msc, bs2 and ms2. So ms is a mobile station 1, bs is a base station 1, msc is a mobile switching center, and then bsc is a base station 2. Okay, so this is just what I'm giving the name. Okay, so in the previous 4 examples, 4 programs, what we were giving, we are giving like a n0, n1, n2 and N3. Okay, just for understanding and just for convent purpose, I'm specifying here it as a MS1, MS2, and BS1 and a BS2 and so on. Okay, so this is these lines used to just to creating the nodes. Next, so next line is to create the what the bandwidth. Okay, so what kind of link we are connecting? That is a we are going to create a duplex link between the MS1 and BS1. Okay, so where it is, you can see the diagram. Here this is MS1 and BS1. This link I'm talking about, this link. Okay, create the link, a duplex link between. Okay, so which node? MS1 node and a BS1 node. So what is the capacity I'm giving? That is a 1 MB. And what is the propagation delay? Propagation delay I'm giving it as a 1 millisecond, and the queuing mechanism I'm giving it as a drop tail. So similarly for BS1 and MSC. Okay, so for second one, this one, BS1 and a MSC. What is the link, duplex link? What is the bandwidth? 1 MB. What is the propagation delay? 10 millisecond. Same thing I have mentioned here. Okay, queuing mechanism is again drop tail. So coming to MSC and BS2, that is this link. Okay, so link number 3. So between MSC and BS2, what is the link type? There is a duplex link. And what is the bandwidth? That is a 1 MB. And what is the propagation delay? There is a 10 millisecond. Okay, so between MSC and BS2, that is a third statement. Okay, so next one, that is a duplex link between BS2 and MS2. Okay, so this link. Okay, so BS2 and MS2, this link, last link. Okay, so next thing is the link creation over. Okay, node creation got over. Next, we have created similar object, then we have created trace file, then we have created a name file. Next thing is we need to create a cell topology. Okay, so why we need to create a cell topology? Okay, so this mobile communication technology comes under what? The cellular technology. Okay, so the communication technology is called as a cellular technology. So why, what exactly this cellular technology? Okay, so here the where in case of this cellular technology, the larger geographical area will be divided in terms of a number of a cells. Okay, so the larger geographical area will be divided into number of a cells, where each cell will be having its base station. Okay, so and each cell will be having some what coverage area. Okay, it is something like what this particular area will be having one access point. Okay, and the each of cell shape will be in the form of a hexagon. Okay, so you can ask why not other shape like a triangle, square. Okay, so in order to divide this larger geographical area, why we are not using circle or a triangle? Because the coverage area. Okay, so with respect to the technically, okay, so when we consider the hexagon shape, in order to divide the larger geographical area, in order to cover the more area, okay, so the performance of this hexagon is higher compared to other shape. So that's why the larger geographical area will be divided in the form of a what? Hexagons. Okay, so how to create the cell topology? Put S, okay, the double quotes, cell topology. Okay, next. So next thing is we need to create the bandwidth. Okay, so we need to create the what? The bandwidth between, that is a MS1 and a BS1. Okay, where it is, MS1 and a BS1. Okay, so what kind of or what kind of link we are using here? Again, it is we are using a simplex, because here we cannot perform the duplex communication, or simultaneously we cannot send and receive the information, because the last node what we considered, it is a your mobile node, and this is your tower, or this is your access point. Okay, so hence I'm using it as a simplex link. Okay, so the bandwidth what I'm assigning between MS1 and BS1 is a 9.6 kb, and similarly for this BS1 and MS1 I'm giving it as a 9.6 kb. Okay, so this one. Okay, then, so coming to the next line, that is $ns insert hyphen delayer. Okay, space MS1 and BS1, space in the bracket new delayer. Okay, so I'm going to insert some sort of a delay. So why am I going to insert the delayer between this MS1 and a BS1? Because so BS1 is your mobile node, and MS1 is, sorry, BS1 is a base station, and MS1 is your mobile node. Okay, so whenever you are sending because mobile node is not a fixed. Okay, it is not a fixed, so it will move, okay, from one place to another place. There would be a chances of the catching up the signals, okay, so by the mobile node, in between the access point and the mobile node will be varying, okay. So for that reason, I'm going to inserting the delayer between this ms1 and bs1, okay. Next, so next step is we need to attach the agent. What are the agent I'm attaching? There is TCP1 I'm attaching to MS1. Okay, so TCP1 I'm attaching to MS1. Okay, and then TCP sync I'm attaching to MS2. Okay, so again I'm repeating, A should be capital, TCP should be capital, S should be capital. This one, TCP sync is attaching to MS2. Right. Next, so $ns connect TCP1 and TCP sync 1, these two, TCP1 and TCP sync 1 connect. Okay, so we have represented previous four programs in the form of a dotted point. So these two are what TCP, these are the agents we need to connect at the end, right? Next, so next thing is $ns connect TCP1 and sync 1 already over. Okay, so next, so set FTP1. Okay, new application, that is FTP1 agent is attached to TCP1. Okay, so where we have attached, you can see here FTP1 we have attached to TCP1 agent. So TCP1 agent is attached to MS1. That means these are the three components comes under one set, and these are the two components comes under one set. That is MS2 and TCP sync 1 is one set, and FTP TCP1 and MS1 is a one set, because this node we are considering it as a source, and this node we are considering as a destination. From here to here I'm sending the information. Okay, next we need to write the finish procedure. Okay, so proc finish. Okay, so here you can either write stop or else you can write finish. Okay, because in the previous four examples, four programs, we have used a word that is a finish. Okay, so this is called it as a finish procedure. Okay, by defining globally, there is a node, opt, okay, nf, ms1 and a bs1. Okay, so next, setting the ids. Okay, so setting the set sid and set did. What is this? So setting the what source id and setting the what the destination id. Okay, so because sid and did is nothing but a source id and a did is nothing but a destination id. Okay, so and then display the what these sid and source id and destination id. Okay, so how put as dollar sid source id and put as dollar did, that is a display the id. Okay, this is again one of the most important the code part which you need to concentrate, because so this is the part. Okay, so where we are going to plotting the graph. Okay, so what is the significance of this line? Okay, so here you can see here, so we have a file called as a get rc. Okay, so we have a file called as a get rc. So this is the file which is already available in your system if you have installed the what your ns2 in your system. Okay, you can just go to home and search it in the search box, that is get rc. Then you are going to see this file which is already available in your folder where you install your program. Okay, so assume that the path what I in my system, it is stored in home. In the home again I have a isc, then in isc I have one more part as a exe56. Okay, but while executing I'll show you because again if you're not change this thing, it may show you the error, because the path may be different from one system to another system, right? The path may be different from one system to another system. I'll show again this path is changing in my execution program part. Okay, so this is the path where my get rc program is available. Okay, and then we have one more file called as a raw2xg. Okay, you have to remember this thing, raw2xg. Again, this is the path where these raw2xg and get rc is available. Okay, and here this s is a what source, and here this m is the message. Okay, and these values will be dumped on a plot xgr. Okay, so this will be pushed to plot xgr file, and then similarly for this value second line, that is okay, so execute, and again one more get rc. Okay, so s is a source and the sid is the just it is the id of the source and a destination. Okay, S is representing the source, and -d represent the destination. Okay, so these are values will be again dumped over the out.tr. Okay, and this is the path of the raw to exe file where it is stored or where it is available in my system. Okay, after installing the ns2. Okay, so again what it will do, it will dump all the files onto plot htr. Okay, so here the interesting thing is we are not going to write awk script. Okay, instead of that, what we are going to do, we are going to use a web trace file. Okay, so web trace file we are going to use. Only tcl script is enough to just understand or study the performance of this gsm and cdma. Okay, next what we're going to do, so next execute ex is nothing but the execute dot xgpg2. Okay, so these values will be dumped. Okay, so on this what xgpg2 dot awk. Okay, this plot xgr value, whatever the values you are going to write, okay, or going to store in this plot xgr, so that will be transferred to dot slash xgpg2 dot awk file. So from here it will plot the awk file. That's why we are not going to write a what awk script here. We are just writing the tcl script in this these two programs. Okay, and then so execute xgraph plot xgr and. Okay, so in order to plot the graph by using a xgraph. Okay, xgraph is again you can say software or a tool. It will be installed whenever you are going to install ns2 in your system. Then exit 0. Okay, then exit 0, then dollar at ns 0.01 start the ftp, and then at ns 2.0 it should stop and run the simulation. Okay, and so here we can see the here we need to concentrate on this part. So whenever we are going to write the program. Okay, so how we are going to see the output, I'll show you the output. So these programs you can just refer. So I think the program of your manual contain old program, so can no need to copy that program, just refer these programs. Okay, so this will be pushing to you people in your WhatsApp group or in your mail. Okay, so where is the output? Let us see. This is CDMA. Okay, so this is what the output you are going to get. This is what the graph you are going to get at the end when you run the simulation process. Okay, so here you can see the different colors. There is a red and a blue. Okay, so there will be no any continuity with respect to the red will represent the what the packet, and this the blue will represent the what acknowledgement. Okay, so when you plot the graph, that is with respect to time and a packet, there will be no any continuity. Okay, some packet will be sent and again drop, some packet will be sent again disconnection, some packet will be sent again disconnection. Okay, this is what due to the lack of bandwidth availability in case of a 2G. Okay, and this is how we are going to obtain the trace file after running the after performing the simulation process. Okay, and similarly when you run the what your CDMA program, so how, only thing is you have to change the bandwidth. I'll tell where to change the bandwidth. Okay, so this is how you are going to obtain the graph part. So when you run the CDMA program, you can see here, so there will be a continuity. Okay, so but in previous program we have seen like there will be no any what continuous continuity with respect to the packet and the acknowledgement, but here there will be a continuity with respect to the packet and the acknowledgement. Okay, so due to the availability of enough bandwidth, okay, to do the communication. Okay, so this is how the trace file will be generated at the end. Okay, so whenever you are writing the what AWK this one CDMA program, so only thing is you have to change this bandwidth. Okay, so here you just change it as by 364. Okay, so I think I have already, I'm having this copy. I'll show it. You can see here. So only this part you have to change. That's it. Okay, instead of that 9 point some value, just change it to 364 kb. Okay, so then you are going to get the graph, CDMA graph you are going to obtain. Okay, so this is all about what the description about the program number 5 and the program number 6. Okay, so let us see the execution part, how the program should be or how we can run the program. Hmm? Pin ಮಾಡಲಾ? Okay. See, I suggest you people to create a separate folder on your desktop whenever you are typing or whenever you are running these two programs, because we need to copy that web trace file. Okay, so first create a separate folder on a desktop by any of the name like program 5 or GSM. Okay. ಈ ಕಡೆ ಬರ್ತಿಲ್ಲ ಇನ್ನೊಂದು ಕಡೆ. Screen is visible to you people? Can you able to see the terminal? Can you respond both the sides?
Yes, sir. Yes, sir.
Okay, fine. First GSM run ಮಾಡಿ sir. So what is the command? ns filename dot tcl. Okay, so you may get some errors. You can see here, could not execute xgpg, no such file or a directory. So what you have to do for this? Go to home. Okay, you can see the procedure. So this procedure you have to do by yourself. Okay, so go to home, then you can just search xgpg2. You have to copy that file. Okay, already you can see here. So why we are not writing that file, awk file? Because of this file. Okay, xgpg2. This is what the error you are getting. Okay, so when I'm running the program, so I'm getting the same error. So what I have to do? I have to just copy that xgpg2 file in the program where I'm executing my program. Okay, I can give the proper path name, that is a whether you are doing whether you are doing through the desktop any folder, okay, or any of the directory. Okay, you can provide the proper path, then you can run. So I have given the okay, again you need to copy one more file. You can see here, so web.tcl. okay, so you have to remember these 2 points. So one is xgpg2 file and one more is web.tcl. so these 2 files should be copied. Okay, so these 2 files should be copied in the folder where you are executing these program number 5, that is GSM program, and the 6th program. Okay, don't forget, otherwise you may encounter with the errors. Okay, then suppose if I copy, then how to run? ns gsm, there is a file name .tcl. Okay, so CDMA ಬರ್ತದೆ ನೋಡಿ. So can you able to see here? Okay, so this is the CDMA output actually. So this is the GSM output. Okay, so you have to run separately. So this is the below line. You can see here these below line are representing what the GSM output. This part. Okay, and this horizontal part representing the what CDMA. I think the output is getting jumbled. Okay, so let me clarify it clearly. Can you able to see here? Okay, so this is the output of a your GSM program. Okay, so what I have shown here in your the manual. Okay, so this is how we are going to get the output with respect to whatever GSM. Okay, so there will be no any continuity. There is no any the continuity with respect to the packet sent and acknowledgement. Okay, so here you can see that has been represented in different colors, like the red color represent the packet and orange color represent the acknowledgement. Okay, there is no any what the continuity with respect to the packet sent and acknowledgement received. Okay, so coming to second program. See, specifying path is very much important. Okay, so you have to remember how to provide the path. Okay, so this is the output of a CDMA. You can see here, so green line and a blue line. Okay, so there will be a continuous continuity with respect to the packet sent and acknowledgement. Okay, that means we have a what sufficient or a higher bandwidth in case of a CDMA the compared to a GSM. Okay, so wider bandwidth due to the availability of a spread spectrum or a spreading concept in case of a CDMA. Okay, so this is what the conclusion is. There will be a continuity with respect to the packet sent and acknowledgement in case of a CDMA, but when it comes to the GSM, there will be no any continuity with respect to the packet sent and acknowledgement. Right. So this is all about the program number 5 and program number 6. Both programs are same, only one value, only in the two places you have to change the value. Right, very simple. Okay, and how to I'll show you the path. Okay, so in the program part I have shown you the path. Okay, sir, ಅದು ಇದು open ಮಾಡಿ get RC ಮತ್ತೆ ಇದು. So how to set the path? Okay, so here you can see this one, home CS3 NS all in one 2.35 NS35 get RC. So till here it is path. Okay, so what you have to do, you have to just go to home, you have to search for get RC file and 2xg raw 2xg file. Okay, so just copy that file. Okay, this is not a standard value, this is the path where my get RC and raw 2xg files are available. Otherwise, so one more thing you have to do, so either you can copy that path or else you can copy these two things in your program folder. Okay, that will also work. Okay, so but here what I am doing, I'm just copying the path where I have stored where this get RC and this raw 2xg files are available. Okay, search get RC, search ಕೊಡಿ ಸರ್ get RC ಅಲ್ಲ ನೀವು ಕೊಡಿ ತಾನೇ ಬರುತ್ತೆ path. So you can see here raw 2xg. Okay, so where it is here, raw 2xg. Okay, so what is the path? And the top you can see here home ns all-in-one 2.35, then slash ns 2.35, then bin, then slash raw 2xg. After that one more file, that is a web.tcl. Okay, so where it is, if you just search that file, then again it will show you the path where that path is available. Okay, so if you could not find that directly while searching, then you can just go to, you can just click on the home and in search part you can just give the that particular name. Okay, so get RC. Raw to exe we have seen, that is this is what the path I have copied from the location where this raw to exe file is available. Okay, so this is the get RC. You can see here it has been highlighted. So get RC is again, it is available in the same folder. Okay, so same path, home ns all in one 2.35, then slash ns 2.35 slash bin, then slash get RC. Because these things you have to copy. So this is all about the program number 5 and the program number 6. Fine. So any doubt? ಅರ್ಥ ಆಯ್ತಾ? Yes. Okay, so try ಮಾಡಿ ಒಂದ್ಸರಿ. I think yesterday some of the